Hello everyone, I say Nawaz and welcome back to my YouTube channel Petroleum Universe. So in today's video we are going to see, as you can see in the figure, that we are going to see about porosity. So it is nothing but the basics of porosity. As you can see in the figure that as the sand grains are moving away from each other, so the porosity is increasing and at last we have a high porosity. Okay, so obviously we know that the porosity comes into the picture when we have a reservoir rock. So that reservoir rock comprises of the three things, which are nothing but sand grains which are solid in nature, and different sand grains are attached to each other with a material called cement, or the sand grains which are attached to the walls of reservoir rock with the help of cement. And apart from that, whatever leftover space will be there in the reservoir rock, that is considered to be a void space or a pore space. As you can see over here, this empty blue space is nothing but a void space or a pore space. Okay, so now let us quickly see the definition for porosity. So porosity is nothing but it is a measure of storage capacity of fluid, or I can read the exact definition is like: the porosity of a rock is measure of the storage capacity that is capable of holding a fluid. Remember that here I have mentioned the fluid. So here fluid means fluid comprises of three things, which are nothing but oil, gas and water. Okay, so apart from this, if you mathematically see that quantitatively, the porosity is nothing but it is a ratio of pore volume to the bulk volume. So we are going to see what is pore volume and bulk volume in detail in the next two slides. So apart from that, as you all know that the porosity is denoted by this particular symbol, and it is we called it as phi, and the units for porosity is like, usually we measure in terms of percentage, but it's a dimensionless quantity. The reason behind that is it is as we have studied in a previous slide, that porosity is nothing but it's a ratio of pore volume by bulk volume. So volume upon volume, if we divide, then there will be no units. As you can see over here, that porosity is equals to pore volume by bulk volume. This formula we can use if we exactly have pore volume and bulk volume. If we have pore volume, let us suppose that we don't have any kind of pore volume data, or we can't find any kind of pore volume, then by using grain volume you can also calculate porosity as by follow these particular steps. So as you can see over here, the porosity is equals to bulk volume minus grain volume divided by bulk volume. So you can consider one thing, that bulk volume is considered to be the total volume. So the total volume is nothing but pore volume plus grain volume. So if we have to find the pore volume, then obviously that pore volume will be equal to bulk volume minus grain volume. Okay, so if you just simplify this, bulk volume by bulk volume minus grain volume by bulk volume, so that will give you porosity equal to 1 minus grain volume by bulk volume, right? So I hope you understood that if you even have grain volume instead of pore volume, then also you can find porosity by using this formula, which is nothing but phi equal to 1 minus grain volume by bulk volume. So these are the porosity types which we are going to see, but our only concern is about absolute porosity and effective porosity. This you can study by your own you can follow any kind of textbook or Google to find out the definition of these kind of porosities, but our concern is for today's topic is absolute porosity and effective porosity. Okay, so let us see those definitions. Right, so as I wrote here, the total porosity is nothing but the ratio of entire pore space. Okay, means if you consider this particular whole space, means blue color whole space of this particular figure, so that particular whole space divided by the bulk volume, means the volume of whole rock, will give you the total porosity. And apart from that, if you consider an effective porosity, then whatever pores are interconnected, as you can see that these pore and these pore are interconnected, and over here it follows the same path which are interconnected to each other. So this particular pore space is considered to be an interconnected pore space. So that pore space, if we divide it by bulk volume, then it is said to be an effective porosity. Okay. Then we have to note that if you have very fine sand grain, then the total porosity can be approximately or will be approximately equal to the effective porosity. Okay. So let us see the next one. So here we generally have two kind of method to determine how to determine porosity. First is direct method, and second I name it as indirect method, but you can but in textbook you can find out as water evaporation method. Okay. So in direct method, what we are doing is, first by using the data we are finding bulk volume, then either we have to find a grain volume or pore volume, then by dividing pore volume by bulk volume we can find a direct porosity. And when you consider an indirect porosity, so what will happen in this kind of determination is like you will get an dry core sample. So first you have to estimate the weight of that dry core sample. Then you have to saturate that dry core sample 100% within any kind of solution. Okay. Now I will consider as brine solution, right? So after saturating the sample with brine, so you may observe that the weight of the sample might get increased, right? So that increase in weight will indicate you that how much volume of brine has enter into the sample, right? So that much volume, so that much amount of brine solution is nothing but your pore volume. So how to get that pore volume in terms of calculation is like, after you have saturated core sample 100% with the brine, then you have to take a difference between the weight of wet and dry core sample. So as you got the weight of the brine, right, as you got the difference of weight, which is nothing but a brine weight, so that you have to divide divide by the density of the brine. Okay. Or whatever fluid you are considering, that you have to divide by that particular fluid density, right? So by doing this particular operation, by doing this particular process, you may get the pore weight, right? Then after that, by using the data given in the question, you can calculate the bulk volume. Then obviously you have, now it is much more enough for you to calculate porosity if you have pore volume and bulk volume. But you have to note one thing, that whatever calculation you are doing, it will come in terms of decimals. So if you need in terms of percentage, then you have to multiply your answer with 100 to get porosity in terms of percentage. Okay. So as you can see over here in this slide, that I have shown you one problem, which is nothing but the given data is core dimensions as length equal to 10 centimeter, breadth equal to 4, width equal to 4 centimeter. So here you can see that the weight of dry form is 282.4 grams and weight of wet form is nothing but 300 grams. So you have this both data, so you can consider that this is an indirect method of porosity determination, or you can say water evaporation method, right? So here I am saturating the core sample with the brine. So for calculating pore volume, I should even have the density of the brine, which is nothing but 1.1 gram per centimeter cube, right? And apart from that, you might have seen in my previous videos. This is actually, I consider a same example what I have explained in the previous video. So not to worry, I will just mention in the description the link of my previous videos which are related to porosity, so you can understand in better way over there. So that's an end for today's video. So if you like this video, just hit like, share, comment and subscribe to my YouTube channel Petroleum Universe. And apart from that, in the next video we are going to see what are the parameters, or what are the properties which are affecting porosity, right? And that's it for today. Hope you liked it. So please press the bell icon to get a latest notification of my videos. And that's it, my friends. Bye bye.